Mr. Prasad Kulkarni. He is responsible for the promotion of e-factory solutions at Mitsubishi Electric India. With an engineering background, Mr. Prasad has a master's degree in instrumentation. He also established industrial automation implementation credentials for smart manufacturing and IIoT communication protocols like OPC UA, MQTT, MTConnect, and other industrial communication protocols of OT systems. He is responsible for promotion, partner development, and sales support for e-factory solutions, Industry 4.0, digital manufacturing in industries like automotive, pharmaceuticals, and food and beverages, etc. on pan-India level. He contributes in pre-sales activities that interprets and translate client requirements into a technological solution that can be configured from a standard set of offerings. Today, Mr. Prasad will be talking about e-factory solutions accelerating the manufacturing. Let's welcome Mr. Prasad.
So while we are listening from half an hour, we have listened to various traceability ideas, traceability definitions, and what kind of traceability solutions implementations should be in the place that we have been listening to. But I would like to more talk about automation as well as traceability in this my presentation. So what we call is the e-factory. So basically you have been listening to various terms like smart manufacturing, industry 4.0, digital transformation. Similarly, Mitsubishi Electric call e-factory. So e-factory is a term name given by Mitsubishi Electric Corporation Japan, and we have been promoting this e-factory concept all over the globe, and we are promoting this e-factory concept also in India very aggressively. Talking about our corporate strategy, so our corporate mission says Mitsubishi Electric Group will continually improve its technology and services, and by applying creativity to all aspects of its business. So while doing so, we try to enhance the quality of life in our society. So as a company, as an organization, we are into 4 different sectors. One is the life, where we have solution like VRF systems, SS systems. Then we are into industry, where I am belong to. That is factory automation industry division. Then there is a division called infrastructure, where we have solutions like elevators, lifts, and there's a division called mobility, where we have solutions for metro transportation systems. But today I am more going to talk about automation and traceability. So these are various products that are under our product basket, right from PLCs, HMIs, drives, then some mechatronic products, then industrial robots, cobots, some of the rotating equipment, edge computing products, power distribution products, and software packages. Talking about manufacturing in the digital transformation era, if I have to talk about, there are a lot of advancement happening in the industry. If you look at sensing, so there are various stages, right? When you collect data, there's a first level is the collection of the data. Then you have to communicate that collected data to some data destination. Then you have to process the data, and then you have to analyze the captured data, and you have to extract meaningful information, whatever data you have captured, right? So there are a lot of advancement happening in each stage. So if you look back, let's say 10 years back, so we used to sense data using some real-time sensor like pressure transmitter, flow transmitter, that used to give some 420 milliampere output, and that used to go to PLC, and then we used to visualize the data on HMI or the SCADA. But today there are some sensors available in the market which basically not only sense the data, but it also pushes the data into some IoT platform. So it pushes data to the cloud platform. So that kind of advancement has happened today. And if I want to talk about high-speed communication, then there are a lot of advancement also happening in the communication. If you look back, then there are standard communication like Modbus, Profinet, Profibus, something like that, right? But today, on top of this communication, there is an additional communication network technology available, that is TSN. And TSN is basically time sensitive network, which talks about basically time synchronization, which talks basically about data sharing, handling that huge data into a number of packets so that data can be flow without any hassle. Then there's a data processing. So we have seen typically in manufacturing, in automation area, we used to have PLCs for processing the data, but that processing was very much limited to that particular equipment or that particular process. But now if we have to handle the large amount of data, the big data, then we have now edge computing and cloud computing services that can be utilized for the processing and handling the data. Then there's a data analysis again. We used to have various algorithms also available in the PLC in terms of feedback control, feed forward control, but that was very much limited to the particular equipment and the process. But now we have AI and ML or blockchain, what Mr. Balaji has explained about, that can also be implemented, and captured data can be converted into meaningful information. So these are the various advancement happening. Talking about manufacturing challenges, so what we see as a automation solution provider, we see there are a lot of manufacturing challenges, but we have categorized those challenges into three main parts. One is the non-standard processes and user interfaces. So where we have seen there is a data connectivity losses. So we want to basically provide a solution which will give you seamless data connectivity, whether your existing system are basically new system, old system, legacy systems, whether it has a standard protocol or non-standard protocol. So irrespective of your uh, existing system data source, we have a ready-made solution which can basically just plug and connect to the existing data source and capture the data. Then second challenge is about labor shortage. So when we say labor shortage, it is basically about skilled labors. So we have seen in the manufacturing there are various lines where humans are working, and that kind of job can also be handled by robots. So we ensure so this repetitive task can be replaced by the robots and the cobots. So we have those kind of robotic solution which can handle this kind of challenges. Then we have seen another challenge, that is passing down long established skills. So we have seen on a shop floor there are some devices, or there are some equipments which are handled by very skillful laborers, and if that particular skillful labor, if he leaves the job of, or he leaves the organization, then his knowledge is basically don't get passed to the next person who is available on the shop floor. So that is the one challenge that's what we have seen. So we have come up with a solution that can take care of all these challenges, and we say it's a complete e-factory solution. Now let's try to see what is basically Mitsubishi Electric solution for the manufacturing. And when we say e-factory, so in a simple words, I would like to explain what is e-factory. So e-factory is a comprehensive solution that leverages latest digital technology like big data, IoT, edge analytics, advanced robotic solution, simulation software solutions, and we try to build a technological ecosystem that help our customer to achieve digital transformation in their manufacturing environment. So that's all about the e-factory as a solution, as a definition. So we have launched this concept way back in 2003, and as the technology is emerging year by year, we are also trying to evolve our e-factory concept. So on right hand side, you can see this is our general architecture of e-factory, which touch upon various aspects of manufacturing. One is basically shop floor, then there is the edge computing and the IT system. So you can very well correlate this architecture with ISA 95 architecture, which also talks about level 0, 1, 2, 3, and 4. So level 0 is basically talks about sensing the physical parameters. Level 1 basically talks about controlling those parameters. Level 2 is basically visualizing, and level 3 is about the manufacturing execution, and level 4 is the ERP. So when we offer e-factory solution, we also touch upon all these aspects, and over the period of time we also have realized alone Mitsubishi cannot offer each and every solution. So for that we have our partner ecosystem. Using that partner ecosystem, we have made various categories. One is a software category, device category, and SI category. So if we talk about the traceability at this moment, then for example, if I want to achieve traceability for any manufacturing plant, then I have to make sure there is a serialization in place. So for that serialization, I need to have various sensors which will capture the data. So for that we get connected, we collaborate with our device partner who can help us with necessary devices that can be integrated on a shop floor, and that the data can be captured. Similarly, we have system integrator partner who takes care of basically integration of any third-party devices. In manufacturing, there could be automation system from Mitsubishi, Siemens, Allen Bradley, right? So we try to collaborate such partners who has expertise on this kind of handling this kind of automation system. Then there's a third partner, is a software partner who help us in the solutions, in the software solutions where we do not have any presence. So using all these collaboration, e-factory alliance partner collaboration, we offer our end-to-end solution. And whenever we offer our e-factory solution, we try to keep our solution as standard as possible. So whether it is level 1, whether it is level 2, or whether it is a level 3, we try to keep our solution as standard as possible, and we try to use only standard products. So this is overall e-factory architecture, we can say. You can see this is production shop floor. So at each and every level, we use our e-factory concept. So we can see there are some devices, there are some equipments where we have implemented AI using our edge computing product. This particular product is powered by a software called Edge Cross, and so this e-factory concept can be implemented for one plant or for the multiple plants. Now talking about overall value proposition, what we offer as a automation solution provider or what we offer as a e-factory solution provider. So basically we take care of complete manufacturing operation management. Then we have solutions like augmented reality and digital twin, then edge analytics and advanced robotic solutions. This is about our overall solution capabilities. So you can imagine this is any manufacturing shop floor that may have various factory automation devices or systems. These systems could be from different automation supplier. It could be Mitsubishi, it could be Siemens, it could be Schneider, Omron, Rockwell. But irrespective of existing data source, irrespective of existing automation system, irrespective of its existing communication protocol, there are ways to capture the data. So we have two ways to capture the data. One is using data collector, that is the hardware gateway, and second is through the software gateway. So based on the customer's existing infrastructure, we decide which hardware gateway or which data collector needs to be used, and we capture the data. And once we capture the data, then we have a complete software platform. We call it Iconic Suite, which has bunch of softwares which basically takes care of your dashboards, reporting, equipment integration, production planning and control, quality management, material management, equipment logbook, traceability, augmented reality and digital twin, and this kind of solutions. We also have edge analytics that is powered by our product called Mail IPC MI5000. So that product is basically powered by software called Edge Cross, where we have some pre-configured AI ML algorithms. So mainly those algorithms are basically waveform signatures, or we call it similar waveform recognition method, that is basically to detect the anomalies in the process. Second algorithm that we have developed is basically MT method, which is used for pattern recognition, identifying the anomalies. And last algorithm that we have developed is basically multiple linear regression analysis method, which is used for finding out the unknown estimations. So we do have a genetics product, and whatever data we capture over here, we process over here, that data can be further given to any big data analytics platform, be it Microsoft Azure, be it IBM Watson, Google Cloud. Then data can also be shared with any data lake or data warehouse, and data can also be shared with any business enterprise applications like ERP. So this is about overall our solution capabilities. When we talk about a complete IT/OT integration, right, we need to take care of securities. So we have complete end-to-end device security. When we capture data, our software also has site to cloud VPN connectivity, where we use X.509 CA certification for handshaking and data encryption. And since our software platform, that is Iconics, is a 7-time partner with Microsoft, we have native connectivity with Microsoft Azure platform. So we use Azure infrastructure to deploy our software on Iconics. These are few sample dashboards that can be developed using our BI tool. So our BI tool is called KPI Works. So it's a business intelligence information tool, you can say, that can be helpful to capture data like OEE, cycle time, MTBF, takt time, efficiency. And this is basically very simple. You just need to drag and drop to desired location, and it will auto adjust its screen. So it's a self-service dashboard kind of thing, and data can be fetched to any ODBC compliant databases, or the data can be shared using web services and VM models. These are few sample dashboards we have developed using the same software for shop floor data visualization. So data could be manufacturing data could be utility data. So based on the requirement, we can offer solution. We also have quality analytics products, which is basically real-time statistical process control tool, which has a gamut of arrays of SPCA calculation charts through which we would be able to know whether my existing process is within my threshold. It has various features like interactive charting. So if you are monitoring some graphs, you can zoom, you can pan, you can scroll, or you can add any comments also if there is any deviation. Then there are certain SPC rule for alarming purpose. Combined dashboards are there. Those dashboards can be developed for operator, or it can be developed for the management. It also has complete logic and workflow. The data can be merged to any enterprise system. It has universal connectivity, and it also supports complete scalability. These are some sample dashboards that we have developed using our Iconics tool platform, that our analytics platform. This is SPC chart, XBAR chart, and on right hand side we can see some histogram. Since we have talked about my co-speakers talked about, Mr. Balaji and Mr. Rohit talked about traceability. The same thing again, I am also trying to talk about basically enabling integrity throughout the entire supply chain, right? Mr. Balaji and Mr. Rohit also talked about taking care of complete traceability right from part supplier and up to the consumer. So same thing we are again talking about, where when we focus on one particular area. So basically, let's assume it's a part supplier, and if we want to do traceability for that particular area, then it would be called internal traceability. But we also need to take care of external traceability. So this green thing basically talks about the transportation product flow, how your product flows right from your part supplier to the end customer, and this blue line basically shows how the information flows right from one stage to the another. And the key drivers that ask for the traceability is basically the process safety, constant demand of high quality product, and sometimes regulatory compliances in case of F&B and the pharma. So I have tried to just create one business scenario where I would like to talk about manufacturer using various parts from supplier, then process, and then sell to the end user. So you can see there could be various OEMs who are supplying various components to one manufacturer who basically assemble, who process his product, and then that product is going to the for the export of the local market. And these are basically various information that we need to collect as a part of the traceability. So at the receiving stage, we need to have supplier name, then supplier business identification number, product description, batch number, and the quantity. So these are the few parameters at least that we should capture when we have to ensure the good traceability. When we are at a processing stage, then again product description in each final format, GTN, that is global trade identification number, if it is applicable, then that can be captured. Then quantity, manufacturing date, batch number, the ingredients or whatever components that has been used to manufacture that product. So all that related information has to be there when we look into traceability. Delivery stage, again there are some inputs that needs to be captured. Who is the manufacturer, what is his business identification number, delivery address, and all those things. We are also into AR kind of solutions, where we all must be aware what is now AR being used in manufacturing. So it is mainly being used for the maintenance activity, to perform maintenance activity remotely. It can be used for optimum resource utilization and solve problems faster, and it can be also used for the as a visual assistant.
Yeah, Mr. Prasad, we are running short of time, so
Yeah, I'm
can
about to
conclude. Yeah.
I'm about to conclude my presentation. Just one more. This is about the advanced robot control technology. I'm just playing one small video. You can simply look into the video, and you'll be able to know how robotic solution that we have implemented, that where robot is basically trying to avoid the obstacles that is coming in on his way, and it is accurately recognizing the product and putting it to the right direction, right position. Then edge cross, so it is basically about the process optimization. The technology that we use is a MySART. So MySART is a Mitsubishi's AI proprietary AI technology, where we use our similar waveform recognition function, which basically learns the data and try to detect anomalies. Again, few MT method and MLR methods. Key benefits out of entire solution is basically centralized production monitoring, increase operational efficiency with captured data, then improve product quality and safety, and to give end-to-end traceability to the end user. This is about our overall solution delivery method, right from planning to support phase. And with this, I would like to conclude my today's presentation.